Go.
Hi everyone. So our topic also is geometry. Okay. So to start us off, why teach geometry? Does anyone know what the word geometry means?
Have any ideas of what maybe it can mean? Think about it if you broke it down. Geo, in the word. Earth, okay, good. So anybody have any ideas? The word earth may be in it.
What did you say, Kelly?
I said like meter, kind of geometry, like a meter.
Okay, and what do you use the meter to do?
Measure stuff.
Okay, so we heard earth.
The study of measuring our world.
Oh, let me do it on here.
Okay.
Good.
To measure the earth. You are correct. So basically, understanding geometry is understanding the earth, understanding physical environment, and just reality in general.
Geometry is also the best exercise in clear logical thinking and reasoning. It's needed for important developments in society, such as Stonehenge or architecture. You need basic ideas of logical and any types of shapes, geometry to do anything with architecture. And detailed and precise practical knowledge of geometrical objects has been widespread through most civilized human societies. Okay, so background, history of geometry. So it started in ancient Egypt about 3000 BC. It is believed that geometry first became important when an Egyptian pharaoh wanted to tax farmers who raised crops along the Nile River. To compute the correct amount of tax, he actually had to be able to measure the amount of land being cultivated. So he had to figure out in terms of like shapes how he was going to tax the different farmers and the different lands they had. And then pyramids are made out of square base and triangular faces. So knowledge of geometry was essential. And the earliest record of calculating the area of the triangles dated back to about 2000 BC. The Egyptians from 5000 to 500 BC and the Babylonians from 4000 to 500 BC developed practical geometry to solve everyday problems, but there is no evidence that they logically deduced geometric facts from basic principles. And then next we go to Greece from 600 BC to 480. Thales and Miletus developed modern principles of geometry. Thales is credited with bringing the science of geometry from Egypt to Greece. He studied similar triangles and wrote the proof that corresponding similar triangles are in proportion. Pythagoras, he's best well known for, as we all know, the Pythagorean theorem. He's regarded as the first pure mathematician to logically deduce geometric facts from basic principles. And the Pythagorean theorem just states that the sum of the squares of the length of a right triangle equals the square of the hypotenuse. So you have like a triangle like this. I'll draw it right here. So this is your right triangle, these are your sides A, B, and this is your hypotenuse, so A squared plus B squared is equal to C squared. There. And then Euclid, he's best known for his 13-book treatise, The Elements, which had a profound impact on Western civilization. And he formed the basis of modern geometry that is still taught in schools today. And Archimedes, his works include the treatise Measurement of a Circle, which was an analysis of the circular area, and his masterpiece, which determined the volumes and surfaces of spheres and cylinders. And then more modern developments, René Descartes, 1596 to 1650. He combined algebra and geometry to create analytic geometry, which is just basically like putting shapes into a coordinate system. So either into like an XY plane, like this, or for a three-dimensional, which I know me and Lauren have seen, the XYZ plane, which is like this is XYZ, which is you can use as spheres. Anything like that, anything that's a three-dimensional shape. So he started the analytic geometry, putting things into coordinate systems. And then, lastly, the Van Heel levels of geometric reasoning. So this is from the work of two Dutch educators, Pierre Van Heel and Dina Van Heel Geldof, which gave us a design for geometry curriculum. There are four characteristics of these levels of thought. The Van Heel levels of geometric reasoning are sequential, so students must pass through all prior levels to arrive at any specific level. These levels are not age-dependent in the way the Piaget described development, and geometric experience have the greatest influence on advancement through the levels. And instruction language at a higher level than the level of the student may inhibit their learning, so going beyond the level that they're already at won't help them at all. You need to start from the bottom up, make sure that they've gotten through that first level before you can start on the next level.
So pretty much to sum it all up, geometry has been very, very important, and people have found it necessary throughout all different parts of civilization, and we really need it now too, for students to understand the world around them. So Van Heel's levels help us as teachers to determine where our students are at. Like Keri just mentioned, it's not necessarily age dependent. Usually there's categories of approximately where their thinking is, but the levels are based on what they've learned before, so it's really important to start and to start right. So to start with level 1, visualization, we're going to go through the 5 different levels, but we put up here on the PowerPoint pictures and phrases to help you remember when you're in the classroom what the levels are to be able to visualize it, and then we'll also go through an explanation of them. So as you can see here, the first level is visualization, usually grades K through 3. So this is all about sorting shapes. They recognize them by their appearance, but can't really identify properties yet. So mostly sorting, identifying, describing different sizes, orientation, and what the shapes are in general. The next part, level 2, analysis, grades 4 and 5. We have here, is a rectangle a square or is a square a rectangle? Because at this point, they're identifying properties. They're learning vocabulary, but not necessarily making connections between the different shapes and their properties, but they know vocabulary to describe shapes, and they know the properties of them. As we get to level 3, we have the relationships between the different properties. So this is when they're mostly doing problem solving, using models and property lists. So measuring different parts of the shapes, really being able to break down what the properties are, making those lists, comparing the shapes. And then as we get up to level 4, deduction, this is when you start writing proofs. So doing the reasoning that's involved in geometry. And then to level 5, rigor, this is mostly your typical college level geometry courses. Keri and Lauren are doing right now.
Yeah. Deduction maybe, you might find it in like upper level high school courses, so if any of you have taken classes where you've had triangles and you try to prove why they're similar, or you have like perpendicular and you're trying, or a bisection, anything like that where you're trying to prove how shapes are similar or different, you may have seen that in level 4 upper high school.
And the purpose of our presentation to you today is to mostly explain the importance of starting young and the experiences that you can give students to help them reach all the different levels. Because as we just learned, if they don't hit one, they're not going to hit the next. So why start young? I'll give you just an example. High school students usually find proofs to be pretty difficult. I don't know if you remember, but it's kind of troublesome for a lot of them. And it's found that students enter high school geometry with a low Van Heel level of geometry, which is probably why they're finding proofs difficult. They haven't reached that point yet. So the solution is to give opportunities for informal proofs starting in elementary school, just that hands-on experience to be able to understand geometry.